Geotrig, this is lesson 36, day 2. We are going to talk about boat in the river problems. Sometimes we'll refer to these with planes in the air. I think everybody can relate to this. Anytime that we were riding our bikes or even going for a jog outside, we would rather run or ride with the wind than against the wind. And then maybe even some of us who are driving our cars, if you're on a very windy day and you can actually feel when there's a big huge headwind that comes and hits your car, right? You can kind of feel the car just kind of hesitate just that little bit, and you have to push down the gas pedal. So basically when we talk about boats in the water or planes in the air, we're going to have that effect of that wind. And the rate of that wind or water plays a huge factor on your speed. If you're going with the water or wind, you will go faster. So let's assume same amount of everything is put into it. If you got a tailwind, pushing you along, you're going to go a little bit faster. And if you're going against the water or wind, you will go slower. And that generally kind of makes sense, right? Everybody's felt those effects. So, what I propose then is take the old standard distance equals rate times time, which all of us know, right? I'm going to switch this around actually and say rate times time equals distance. Maybe use that instead because that's the way the directions are set up. If you are going with the water, okay, your boat, you have your boat and you're rowing it with the water, what happens is that your speed, B, speed of the boat, and the speed of the water combine to create that new speed. So if you can row at 2 miles an hour and the river is flowing at 3 miles an hour, when you get in that river and you're rowing with it, you are actually going 5 miles an hour. Make sense? If you're going with the water, you combine your speeds. Time the distance, they say TD, so distance down, time down, will equal a distance down. D with a little d. Now, if you're going against the water or air, it's the boat's speed, B, minus W, the water or wind. So that same boat that you're rowing 2 miles an hour, the same river going 3 miles per hour, but you're going against it, which way are you going? Are you going up the stream? The river's flowing 3 miles an hour, you're rowing 2. Is it enough to make it up? No. So you would take B minus W, 2 minus 3, you'd be going a negative 1 mile per hour, which means you are literally flowing down the river still. Just slower, right? Times the time it takes to go up the stream will equal how far you will go upstream. You will notice that most of the time, what we're going to assume here is that the plane or the boat speed for B is what we would consider in still air or still water. So if you're on a lake and there's no wind, no water, and you're able to then row your boat 3 miles an hour, 2 miles an hour. Okay, and the water is how fast that water is flowing with you or against you. A lot of the times you're going to find you're going to go downstream or downwind faster than you will go upwind. Because you're not adding, you're subtracting it out. Are there any questions? So this is the thing. If you look at these equations, I got B, W, TD, and DD. I got a B, W, TU, DU. I've got 4 variables in the first one, 4 variables in the second, and only 2 of them coexist within the 2 of them. That's 6 different variables in 2 equations. That is not enough to solve for any individual by itself, right? Remember systems of equations? The amount of variables you have has to equal the number of equations you have, and then you can find your unique solution. So what we're going to do then is they're going to give you select values. They're going to tell you, hey, it took them 3 hours to go downwind over a total distance. Or they're going to tell you upwind stuff. And then more than likely, they're not going to tell you how fast the boat in the water is, but they will give you a connection. They'll say, hey, your plane can travel at 4 times the speed of the wind. So there are some things that you guys can do then that are going to be able to eliminate it down to 2 variables, 2 unknowns, and solve. So, are you ready for our first question? It says, question number 1. One day, Shelby found that her plane could fly 5 times the speed of the wind. She flew 396 miles downwind in 1/2 hour more than it took her to fly 132 miles upwind. What was her speed of her plane in still air, and what was the speed of the wind? So basically, how fast is her plane going? How fast is the wind going that day? So to start this problem, I write down the 2 equations. And they are B plus W. If I'm adding to the wind, the plane together, I am traveling which way? Down. And if I'm going to subtract, you're going up. So now I just got to fill those in. What's the connection between the plane and the wind? Does B equal W? Are they the same? One faster than the other? B and W are the rates. How fast are they going? 5 times what? So the plane, B, is the same speed of the wind, but 5 times faster. Or it is 5 times faster than the wind. That'll be helpful. That means I'll be able to get rid of the B's, right? Make them all W's. Ooh. You know that she flies 396 miles down. This first example, I'm going to list them all before I throw them into the equation. And it took her 132 miles up. So distance up is 132. And then we could talk about TD equals TU. Are they the same? This gets a little tricky here too. They're not equal, are they? Someone has more time. Who has more time? She flew downwind in 1/2 hour more than upwind. So TD is equal to TU's time plus 1/2 an hour. Could I say TD minus 1/2 is equal to TU? Yeah, we could do that way too. So now you got to fill it all in, guys. B is equal to 5W. Okay. 5W plus W. TD is TU plus 1/2. Make sure to use parentheses on these things. And TD is 396. Is everybody okay with me substituting all the different pieces in? 5W minus W. Okay, that's easy enough. Time up. Oh, we're leaving time up. Time up equals 132. I think we could simplify that, don't you think? 5W plus W is, so 6W times TU plus 1/2 is 396. 5W minus W. For W, TU is equal to 132. A little bit of moving around. This one doesn't seem like I can do too much yet, but I think I could distribute the 6W. So when I distribute that 6W, oops, wrong one. I get 6W TU plus 3W is equal to 396. We have a problem, Mr. Konchak. We have a W and we have a TU, which is two variables, two equations, yeah? That's not necessarily the issue, but I've got a W times a TU. How are we going to handle that? Divide by what? You know, where? Because not everything's divisible by TU. I can't just get rid of TU. Right? If I divide by TU on this one, it'll cancel here, but then I'll have a TU on the bottom. Or here, this is divisible by TU, but these two are not. Look at this equation. Could I divide both sides by 4? What's 132 divided by 4? I'm just going to quickly do this once. WTU is equal to 40, not 40, is it? 44? Anyone verify that or no? What? 30? 132 divided by 4. 33. Oh, it's a good thing I had someone verify that. It's 33. How can I use that to my advantage? How can I use a WTU equals 33? Yeah. Plug this, which is equivalent, here. Isn't that a WTU? And if I do this, I'll change colors so I can show that. I'm going to put this into here. So I get 6 times 33 plus 3W is equal to 396. I only have how many variables now? Can you solve for W? 33 times 6? 198 plus 3W is 396. Subtract a 198 from both sides. 3W is equal to what? 198. And divide both sides by 3. W is equal to 66 miles per hour. What did W represent? Speed of the wind. We got wind, but here's the cool thing. Once we know wind, multiply it by 5, and you have the airplane in this case. So B is equal to 5 times 66, which is 330 miles per hour for the plane. And you're done. When an airplane flies into the wind, it can travel 3,000 miles in 6 hours. When it flies with the wind, it can travel the same distance in 5 hours. Find the speed of the airplane in still air and find the speed of the wind. So it's set up slightly different. I mean, it's the same equations, but they're giving us different pieces of information. And so your job is to put it together. So try this one on your own, and we'll come back together with this one. Hopefully you have the equations. so we can start to fill in some pieces of information. So what we need to do here is decide what do we know. So travel into the wind. If I'm going into the wind, I'm traveling against our upwind. Up into the wind, right? So du is equal to 3,000. Tu is 6 hours. That's what it says. But wait a minute. If I go with the wind, it's the same distance. So Td is 3,000. Td is 5. That's all we know, right? But if that means I'm getting rid of these 4 variables, in a way, leaving me with B's and W's, that's going to be more, this one is more of your traditional system when you fill it in. Because it'd be B plus W TD, which is 5, equals 3,000, and B minus W times 6 equals 3,000. Was everybody able to make those? How many people distributed the 5 and the 6? How many people said, whoa, 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 that's 5 times that, 6 times that? Why don't I divide by 5 and divide by 6? Wouldn't that make our lives a little bit easier? You guys notice that it's 5 times this group? So that means I can actually get rid of 5 just by dividing both sides by 5. And so you end up with an equation of B plus W is equal to, what's 3,000 divided by 5? Should be 600. And if I divide by 6, then I end up with, whoops, B minus W is 500. What should you do with those 2 equations? Makes it real easy. What's that? You could solve for B, but I think there's an easier way. Just add them up. Can't add those equations? Process of elimination here. Cancel the W's. So 2B is equal to 1,100 divided by 2. 550 miles per hour. And that is your plane. Well, here's the thing. If you go back to this equation, if B is 550, what's W have to be? 50. W is 50 miles per hour, and that was your wind. Boom. We are done. Next problem says, a boat can travel 10 miles upstream in 30 minutes. The return trip downstream takes only 20 minutes. Find the speed of the boat in still water and the speed of the water. All on your own. Go. So, a boat can travel 10 miles upstream in 30 minutes. This one, again, is just kind of like more like the last one. But you got to be careful because this one's in minutes and it's not in hours. So your answer is going to be in minutes. Miles per minute, not miles per hour. Don't interpret that wrong. B plus W times TU upstream, or TD I meant. TD is turn trip takes only 20 minutes. So 20 equals 10, right? B minus W is equal to 30 minutes into the wind for 10 miles an hour. Is this any different, really, than the last problem? Divide by 20, divide by 30, yeah? So B plus W is 1/2. B minus W is equal to 1/3. I'm divided by the 20 divided by 30. That means add them up. 2b is equal to 1/2 plus 1/3. I'm putting it this way so that I can actually do some math and get a common denominator. 3 plus 2 is 5, 6. And then I got to divide by 2. Wait, I'm not going to divide by 2. I'm going to do what instead? Multiply by 1/2. By multiplying by 1/2, I don't have to worry about getting the stupid common denominators and the complex fractions and stuff. I'm just going to deal with fractions straight as they are. And so b is equal to 5/12. You know what b is? 5/12. That's 5 miles per 12 minutes. Or 5/12 of a mile per minute. You got to plug that back in and solve for W. Easily done, right? You just got to make sure to work with your fractions correctly. Any questions? So by plugging back in there, you get W is 1/12 miles per minute, or 1 mile per 12 minutes. This is your homework, guys. The two problems separated by page 259, problem number 1. So 3 problems total, and they're all boat in the river problems. Have a fantastic day.